Okay, derivatives of ln x and logarithmic differentiation is what we're going to do today. So if we have y equals ln x, how you do the derivative of that, the derivative of y equals ln x, it's just 1 over x. Because what you do is you take the derivative, so what you do is you rewrite it 1 over whatever's beside the ln. So it's going to be 1 over x, and then you multiply it by the derivative of x. What's the derivative of x? 1. So that's why it's just 1 over x. So example, what happens if it's not x? What happens if it's y equals ln x cubed plus 2x squared? What happens if it's y equals ln x cubed plus 2x squared? Well, you write it as 1 over what's beside the ln. So y prime equals 1 over what's beside the ln. And then you multiply it by the derivative of the bottom. What's the derivative of x cubed plus 2x squared? 3x squared plus 4x. So y prime equals 3x squared plus 4x over x cubed plus 2x squared. So technically what you're doing is you're writing it the derivative over the top divided by what's in the brackets. But what they do if you do it in steps is you write it as 1 over times the derivative. So what I always say is it's just the derivative of this on the top and that on the bottom. That's what I always do. I don't do this middle step where I multiply them like that. Yeah, you can reduce it. Yeah. Yeah, so you could go an x in the top and take out, and then you'd be left with 3x plus 4. Okay, and then the bottom we could take out an x squared, and we'd be left with x plus 2, and then those could cancel. Actually, the squared would cancel, not the x. Okay, what if I give you find d over dx? So what does that mean for you to find? The derivative. Differentiate means find. Derivative. Y prime means find. Derivative. They're all just different ways of saying find the derivative. So d over dx of ln sine x. It's actually really, really easy. All we do is we take whatever's in the bracket, put it on the bottom, the derivative of it on top, right? So we do with ln. So d over dx of ln sine x equals sine x would go on the bottom. What's the derivative of sine x? Cos x, which is cotan. Yep. Okay, what happens though if we do Differentiate. Y equals the square root of ln x. Whenever we're asked to differentiate and there's a square root, what did I tell you you need to do first? Turn it into a 1/2. So y would equal ln x to the 1/2. The moment you do that, what should it scream that we're going to have to do first? Chain rule. Yep. So we're going to take the half, we're going to drop it in front. We're going to rewrite it to the -1/2. What haven't we done yet? The derivative of the ln x. What's the derivative of ln x? 1/x. So we'd write that as y prime equals, we have a 1 on the top, 1 times, well, this would change, go to the bottom, right? And 1 times 1. So we have a 1 on the top. On the bottom, we'd have a 2 and an x. And we'd have ln x to the 1/2. So that could be written as 1 over 2x square root ln x. One more. Differentiate y equals ln x plus 1 over the square root of x plus 2. Yeah, I just went there. Don't get overwhelmed. That is what the biggest problem is with this question. People get overwhelmed. When you have a ln in front, what's the thing you do? When you have a ln, you take what's in the brackets, you put it on the bottom, you take what's in the brackets and you do the derivative of it on the top. That's it. Don't overwhelm yourself, okay? So we're going to get y prime equals. That's going to go on the bottom, so I'm just going to rewrite it. We'll deal with it in a second. But for now, I'm just going to rewrite it. X plus 1 over the square root of x plus 2. Yeah.
So when you differentiate.
Yep. Yep.
Could I just say that instead of saying ln, or like put that on the bottom like that? Could I just say square root x plus 2 over x plus 1?
Multiply it by it? You would actually have that after, though. You technically wouldn't have it first. Because you're going to have this top divided by that. So you could go the top times that for sure. But it should come after, not before. Okay. F, yours is wrong because just mathematically it's wrong. It's this divided by that. You'll end up working out correctly, but it's not correct. Well, you're doing this divided by this. You're trying to write it backwards. Sure. F equals x plus 1. G equals x plus 2 to the 1/2. So before I write it on the top, I'm going to go do it off to the side, get it all simplified like, and then put it into the top. So I'm not having to rewrite that denominator 8,000 times as I go along. So G times F prime, which is what? 1 times F, or minus F, times g prime. G prime is going to be 1/2 x plus 2 to the negative 1/2 times 1 technically, but I'm not going to do that because it's not going to do anything. All right. Then you're going to have 1/2 x plus 2 to the negative 1/2 all over x plus 2 to the 1/2 squared. What can we do to the top? X plus 2 to the negative 1/2. You are correct. What else should we take out? I'm hoping I've drawn this home. Something better. One-half. When you have a fraction embedded in the inside, you want to pull that fraction out so you can drop that number to the denominator. You don't want to have like crazy fractions in your numerator sitting up there. If not, you're going to have to make common denominators to bring that 2 down anyways. So you might as well take the half out. So if it was a half or a third or a quarter, or even if it was like 6/5, I would take a 1/5 out. Okay? You want to get that fraction out. So I'm going to take a half out from. Now, x plus 2 to the 1/2 minus a negative 1/2 is 1. It should be 1. If not, you made an oopsie, right? So we're going to have 1 left. So we have an x plus 2 left. And then a 1, which is nothing. And I'm going to be left with, oh, and what am I actually left with still? A 2 here. Why is there a 2 there? Because you pulled a half out. When you pull a half out of 1, it's like 1 times 2, so you're left with 2. Then minus x plus 1, because the half and that go away. All over x plus 2. And I can move this down here too, x plus 2 to the 1/2. And I can move the 2 down here. Yeah. Yeah. Because 1 divided by a half is like 1 times 2. So technically, you guys, the ones that don't have the half in them, you're going to end up multiplying that term by 2. If you pulled out a quarter, you'd multiply that term by 4. If you pulled out a 1/5, you'd multiply that term by 5. The one that doesn't contain that 1/5 or the half or the third. So here, that's just a 2. It looks crazy. You're going to end up with 2x plus 4 minus x minus 1 over, you should all have equal signs. 2x plus 2 to the what? What's 1 plus a half? You have a 2x minus x plus 3 over 2x plus 2 to the 3/2. Which still looks ridiculous, but at least you're now just putting that on top of that, not doing all of that and rewriting that denominator underneath it. It gets super overwhelming. Now, we have a fraction over a fraction. What do we always do when we have a fraction over a fraction? We did it in trig. We did, yes. Write them sideways, side by side as a division, and you actually end up flipping the second one to multiply. So you would get, I'll show the step. X plus 3 over 2 x plus 2 to the 3/2 divided by x plus 1 over x plus 2 to the 1/2. But then we would actually multiply. The ln goes away, remember? When you take the derivative of a ln, the ln goes away and you get what's in the brackets below. and the derivative of the brackets above. The ln goes away completely. Okay. The x plus 3 and the x plus 1, nothing in common, can't take away. The 2, nothing in common. But these two are actually the same. This is a half and this is 3/2. So what do we do? Minus them. So a half minus 3/2 is a half minus 3/2 is -1. Now, this is the catch. People are like, do I leave it on the bottom or do I leave it on the top? It stays on the top, but because it's a -1, it's actually going to go to the bottom. We'll do it in 2 steps so that you can see. So you're going to have x plus 3. Whenever you subtract these exponents, no matter what answer you get, you guys, it stays on the top. Okay? So I went a half minus 3/2, I get -1. It stays on the top. Whenever you subtract them, it stays on the top. Now, I might move it to the bottom to make it positive, but when I do that operation, it keeps it on the top. Okay? So I'm going to be left with an x plus 2 to the -1, because I did on the top, and then 2 over x plus 1. We're going to get x plus 3 on the top over 2 times x plus 1 times x plus 2. Try this one. It's going to be differentiate. And then there's going to be parts to it. Yeah, I just want you to do the differentiate all of them. So a f of x equals ln sine squared x. So a little harder because you actually have a chain rule inside the ln. And b, what happens if I give you this? Y equals 1 over ln x. We'll try a few because then it... So we have ln sine squared x. When we have to do the derivative of a ln something, we take that something, we write it on the bottom. So we're going to get f prime of x equals sine squared x on the bottom. The top, we put the derivative of sine squared x. So what is the derivative of sine squared x? Well, I'm going to write it as sine x squared, right? That's what we always do. So we actually have to do chain rule with it. So the derivative of that is going to be 2 sine x to the 1 multiplied by the derivative of sine x. What's the derivative of sine x? So on the top, I'm going to get 2 sine x cos x. What could I do? This is just sine x times sine x, right? It's just a sine x times a sine x. So that one can cross off that one. And you'd be left with. Now, what's cos x over sine x? We'll do B together as well, and then I'll give you 2 new ones because I think people need a little more practice or guided practice anyways. So, bring our ln x up to the -1. The -1 has to be dealt with first. So we're not going to deal with the ln x first at all. We have to deal with the -1 first because we always work our way from outside in. Here the outside was the ln, so we dealt with that first. Here the outside is the -1. So we're going to get y prime equals -1 ln x to the -2. We do chain rule first. Drop the -1 in front, rewrite it, drop it by 1. Okay? Then we do the derivative of the inside. What's the derivative of ln x? 1 over x. So y prime equals -1 over, that can drop to the bottom, ln x to the 2 times x, or x ln x to the 2. Okay, what if I give you this one? Let's see. That would just be nasty. That's a plus sign, but it's kind of, yeah, it got a little curve. It's a plus sign. C is not ln, paying attention. C is not ln of that. If it was ln of that, you'd take that, you'd put it on the bottom, and the derivative of it on top, okay? But it's not ln of that. This is just a quotient rule with a ln in it. That's all it is. So we're going to do quotient rule. F prime of u equals g, which is 1 plus ln u, times f prime, which is 1, minus f times g prime. What's the derivative of 1? Nothing. What's the derivative of ln u? 1 over u. All over g squared. So on the top, you're going to get 1 plus ln u. Because you distribute the 1 and that's what it stays. Minus 1 over 1 plus ln u squared. So it's just going to be ln u over 1 plus ln u squared. This one has a ln in front. Because it has a ln in front, I take what it's in the brackets, put it on the bottom, the derivative of the brackets on top. Okay? So I'm going to get h prime of x equals this on the bottom. So then on the top I have the derivative of that. So derivative of 1, or x is 1, plus the derivative of anything with the square root is to the half, right? So I'm going to do a half, drop it in front, rewrite it to the negative a half times 2x. The 2's cancel. Now, some people will leave it like this, but remember I told you, you can't have a partial fraction in the numerator. So we're going to have 1 plus technically that all over if you left it there, you wouldn't be wrong, but it wouldn't be final. Yeah. Yeah. So we're going to have to multiply the 1 by x squared minus 1 to the half because we need to get the entire numerator over the same denominator so I can divide by the bottom. It's just like when you did trig. You had to have the entire top over one denominator before you could divide by the denominator and cancel in trig proofs. It's the same thing. So I'm going to have to get this to be the same. So I'm going to multiply it by x squared minus 1 to the half. So on the top, I'm left with x squared minus 1 to the half plus x all over x squared minus 1 to the half divided by x plus x squared minus 1 to the half. The moment you have a fraction in your numerator or your denominator, I always write them side by side. Life is just better. And then we're going to get x squared minus 1 to the half plus x over x squared minus 1 to the half times 1 over x plus x squared minus 1 to the half. So on the top, we're just left with x plus x squared minus 1 to the half. And then on the bottom, I'm going to distribute. The reason why I want to distribute is because both of them have an x squared minus 1 to the half. And when I put them together, they're going to make an x squared minus 1 to the 1. So I'm going to go like this, and like this. So it's going to be x times x squared minus 1 to the half plus x squared minus 1 to the half times x squared minus 1 to the half is x squared minus 1. And then they might ultimately, in the end, change these to square root signs. Yeah. You can't because there's two terms. It has to, the only way you can cancel something off is if it can come out of every single term, in the top and in the bottom. But because there's a binomial in the top, we can't. Like I can't take this out of this one. What do you mean? Oh, I get what you're saying. I like that. I thought you meant like here. And I'm like, no. But here, yes. Oh, that's pretty. I like that. Did you erase? It's so pretty. Look at how pretty that is and not pretty that is. Oh, it's like a little Christmas present right there. That's just so nice. You'd have to factor the bottom. They matched. They're like exactly the same. So they just go, they're right. See, like this one is like a perfect replica to that one. So those bad boys can go away. I thought you meant like here. And I'm like, no. But here, absolutely. Now, you guys, they can ask you for a tangent equation too. Because that's the first, because this is just the slope. The first derivative is tangent slope. Plug in the point they give you. Get your x value. Plug in your x and y, get your slope. Plug in your x and y, get your equation. The same thing, right? Once you get to here. Now, if it's like ln of 2, you guys, they're never going to want it as like the decimal. They're going to want it as like, if it's like 2 plus ln 2, that's going to be your slope. 2 plus ln 2. You're going to leave it like that. You're not going to change it to a crazy decimal that repeats, that doesn't stop or whatever, and then you cancel it off and make it a terminating decimal. You can't do that. You can't round. So if in the end when you plugged it in, you ended up with a ln in it somewhere, like for example this one here, if say the point was at 2, they wanted to know what the tangent slope was at 2, you'd get ln 2, 1 plus ln 2 squared. That would be your tangent slope. You're not going to change it to a crazy decimal. Okay? If there's a ln in it, you just leave it. So, question. I'll give you 2 more to work on, and then we'll go through them, because I feel like if I let you go, it might get scary. So E is G of R. E is G of R equals R squared ln 2R plus 1. So R is the variable because it's in the brackets. Y equals ln x over x squared. And then G is ln secant x plus tan x.